So today we're talking about what is an acid and a base. Acids and bases are defined in three ways. You're going to learn about two of them now, and you'll learn the third one when you take AP Chemistry. So the two different definitions of an acid and base are first the Arrhenius definition. So the Arrhenius acid is the one we were just talking about when we talked about naming, and that's the one that basically says that acids contain hydrogen ions. An Arrhenius base says that bases contain hydroxide ions. So examples of acids would be HCl, H2SO4, H3PO4, hydrochloric acid, sulfuric acid, and phosphoric acid. Lithium hydroxide, calcium hydroxide, and iron 3 hydroxide would be examples of Arrhenius bases because they all contain hydroxide. It was determined, though, that that was not the only definition of an acid. Bronsted-Lowry came across another way that acids behave, and that is to donate protons or hydrogen ions. They're called protons because a hydrogen ion has the same nucleus as the hydrogen ion's nucleus is the same as a proton. It has a positive 1 charge and a mass of 1. So they donate hydrogen ions. Bronsted-Lowry base definition says that they accept hydrogen ions. Okay, and so we can identify acids and bases in that way. So according to Bronsted-Lowry, in this example here, we need to determine what donated a hydrogen, and that's the acid, and what accepted a hydrogen, that would be the base. So if we look here and we follow what happens to the hydrogens, here you have H2SO3, over here you have only HSO3. So H2SO3 gave a hydrogen ion to the water. So since it gave away a hydrogen, it's the acid. Water accepted the hydrogen. I know that because now there are 3 of them here. That's the base. We also have names for what is produced. So the acid becomes the conjugate base because it now has 1 less hydrogen. The base becomes what we call the conjugate acid because it now has 1 more hydrogen. Let's look at another example. Again, we're just following the hydrogen. So here you have acetic acid, which is HC2H3O2. It has 1 hydrogen in water. And we notice here that the acetate ion here has no hydrogen with it. And so this hydrogen was donated to the water to form H3O+. So HC2H3 is the acid, water is the base, and then the base, when it gains a hydrogen, becomes the conjugate acid. The acid, after it loses its hydrogen, is now the conjugate base. In C, we're going to have a similar example where you have H2S in water, making H3O and HS-. So here we see that H2S comes to 1H, and so it gave a hydrogen away to the water, which now has 3. So here you have an acid, the base, the acid becomes a conjugate base, the base becomes a conjugate acid. And that is the Bronsted-Lowry definition. So all I want you to do now is to stop the video and to practice on your worksheet that follows this video. And I'll come back to you in a moment and when you're done, and we'll go over the answers. So pause your video now, complete the practice, and then watch me go over the answers. Alright, so now that you have completed the problems on your own, let's see how well you did. So HSO3, if you find that thing over here, it has 1 less hydrogen. So it gave away its hydrogen, so that's the acid. It gave its hydrogen to the water, which is the base. So now H3O+ is the conjugate acid, and SO3, 2- is the conjugate base. In E, we see we have NH3. Over here we have NH4. So now this gained a hydrogen. So if it gains a hydrogen, it's the base. Where did it get the hydrogen from? Well, here you have H2O, over here you only have one H and O. So this time the water gave away the hydrogen. So it's the acid this time. So the base still becomes the conjugate acid, and the acid still becomes the conjugate base. In the next problem, we see HF, and then we see F by itself. That must mean that H gave away its hydrogen. So if H gave away its hydrogen, it's the acid. HSO3 gained a hydrogen, so that's the base. Then the acid becomes the conjugate base, and the base becomes the conjugate acid. The last problem, HNO2 and HS minus. So here we have an H. We find NO2 is without an H. So this H had to go over here to HS and make H2S. So that makes this one the acid. It gave away its hydrogen. This is the base because it accepted a hydrogen. The acid becomes a conjugate base. The base becomes a conjugate acid. Make sure you note in your notes that water can act as an acid or base and is therefore known as amphoteric. You must know this term. It will be on your test.